Hi everyone, welcome to another video. This is going to be molarity on Module 5. We're going to do some practice problems, so let's get started. Okay, so let's read this question. It's asking, determine the molarity for 294 grams of phosphoric acid in 2 liters solution. Okay, so first of all, what is our formula for molarity? So molarity is equal to moles per liter, right? Okay, so we have our liters check, but we don't have our moles. So how would we find moles? So to do this, we would start with our 294 grams of phosphoric acid. Recall phosphoric acid would be H3PO4. Perfect. Okay, so let's find our moles. So we know that 1 mole of phosphoric acid is equal to how many grams? So grab your calculators and your periodic table. So hydrogen is equal to 1 gram. We have 3 of those. That's equal to 3 grams. Phosphorus is equal to 31 grams. And then we only have 1, so that will just remain like that. So yeah, 31 grams of phosphorus. And finally, oxygen. So oxygen is equal to 16 grams. Multiply that by 4. That gives you 64 grams. Add all of these up, so you have your 31 plus 3 plus 64. That gives you 98, I'm sorry. That gives you 98 grams total. So you know that per mole of phosphoric acid, you have 98 grams of phosphoric acid. Perfect. Okay. So now what we do, we would divide 294 grams of phosphoric acid over 98, which plug it into your calculator, divide it gives you 3. So we have 3 moles of hydrophosphoric acid, sorry. Okay, perfect. So now we have our moles, right? So to calculate our molarity, we would just do our 3 moles over our liters. So we would do 3 over 2, that gives you 1.5. So we have 1.5 molar. And this would be your answer, guys. Perfect. Now going into the next problem. Okay, it says, calculate the number of moles and the mass of the solute in 300 milliliters of an 18.5 molar sulfuric acid. Okay, so let's recall our formula again. Molarity is equal to moles over liters, right? And it's asking us to calculate the number of moles. So this is what we want. So yes, we have our liters technically, even if they're in milliliters, and we have our molarity. So what do we have to do? First of all, let's isolate the moles, and this gives you moles equals to molarity times liters. Perfect. Okay, and now that we have this, so we have milliliters, so we have to change that to liters, right? So we know that 300 milliliters, so we know that in 1 liter there are 1,000 milliliters, right? So divide 300 over 1,000, that gives you 0.300 liters. So now you have your liters part of your equation. Now to find your moles, you would divide your molarity, you would multiply your molarity, which is 18.5 molar times your 0.300 liters, and that should give you the moles. Okay, so grab your calculators, guys. 18.5 times 0.300 is equal to 5.55 moles. And this would be your answer. Perfect. Okay, so let's get into a more challenging problem. So this problem says, how many liters of a 0.350 molar hydrochloric acid are required to react 1.95 grams of magnesium in the single displacement reaction. Okay, and this is our single displacement reaction. Okay, first of all, let's check if this equation is balanced. So we have 1 magnesium on my reactant and 1 on my product. Check. 2 hydrogens, and 2 chlorine. So yes, this equation is in fact balanced. So now that I've done this, we want to find our moles of magnesium first. So we know that we have 1.95 grams of magnesium, right? And we know that in 1 mole of magnesium, there are, look at your periodic tables, guys. Magnesium has a mass of 24.31 grams. Okay, perfect. So now do the math and find how many moles of magnesium are there. So 1.95 over 24.31 gives you 0.080 moles of magnesium. Perfect. Okay, so let's take this into consideration for our molar ratio. So we have this amount of moles of magnesium, right? Actually, I'm going to do it down here. So 0.080 moles of magnesium. And looking back at our equation, because we want to know our hydrochloric acid, remember. So looking back at our equation, when there is 1 mole of magnesium, how many moles of hydrochloric acid are there? There's 2 moles of hydrochloric acid, right? 2 moles of HCl. Okay, now we would do the math for this. So multiply your 0.080 times 2, right? Because moles of magnesium cancel. And that gives you 0.16 moles of hydrochloric acid. Perfect. Okay, so now we have our moles, right? We have our liters. I'm sorry, no, we don't have our liters. And we have our molarity. So remember our equation, molarity equals moles over liters. And we want to find our liters, right? So our equation would now be liters are equal to moles times molarity, right? I'm sorry, no, not times. Moles over molarity. So we would do our moles, which are 0.16 over our molarity, which is 0.35. And this would equal to, grab your calculators. So 0.16 over 0.35 gives you 0.457 liters. And that is how you would do this problem, guys. Okay, I hope these problems are helpful, practice, and you can eventually get really good at this if you keep practicing more molarity problems. Thank you for watching. Have a great day.